Audio Jungle. Audio Jungle.
All right, now we are going to discuss the Mohr circle. Mohr circle for plane stress. Right? Mohr circle for plane stress. Now, in this case, we know it's a graphical representation. Okay, it's a graphical representation. It's a graphical representation. The graphical representation. Okay, of stress system. Of a stress system. All right. Now, here we have to see the equation of Mohr circle. Okay, so how to get that? So we directly jump to the equation of Mohr circle. Equation of Mohr circle. First we'll write the equation, then we'll draw the uh, graphically we represent through the circle. Okay, so first we know the normal stress. For the system I'm considering, this is the system basically. Okay, and for this particular system we have the biaxial stress system. This is what sigma y. This is what sigma y, obviously what sigma x, and this is what my x. This is what tau xy, what tau xy, can say this is just equal and opposite complementary stress tau xy. Okay, now for this particular case, if we can draw one oblique section for this particular plane. So this is the oblique section. From vertical it is making angle theta. This is the oblique plane now, and oblique plane we have a normal stress sigma n, and we have a tangential stress which is shear stress or tangential stress which is nothing but tau. And this is Lm, sorry, Lm I have to write, not Ln. Your choice, anything you can write, but we are making practice Lm here. So this is Lm and this is Ln, right? So overall, we are going to talk about the normal stress for this Ln plane, which is the oblique plane. So normal stress on Ln plane. Okay. So what is the normal stress? Is sigma n, and that we already have derived. So directly we can write that equation. It is nothing but sigma x, sigma y by 2 plus sigma x, sigma y, okay, by 2, and this is nothing but cos 2 theta. Then we have tau xy sin 2 theta. And this is the normal stress on the oblique plane. If I say what is the shear stress on Ln plane, shear stress is nothing but tau, okay, nothing but sigma x minus sigma y by 2. This is sin 2 theta minus tau xy cos 2 theta, right? This is the shear stress. So now having these two equation, based on these two equation, we have to write the equation of Mohr circle. How to write that? So we can rearrange this. How we can rearrange? We'll take equation first. You just say this is equation number 1. We'll go fast a little bit. This is equation 1 and 2. So from equation 1, so what is the equation 1? You just see here. We have sigma n is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 theta plus tau xy sine. We can rearrange this sigma n, take this sigma x plus sigma y this side. Okay, so this will be the value, and now here this side it is sigma x minus sigma y by 2. We'll have a cos 2 theta tau xy, this what, right? And you just say this is equation number 3. So, and tau is equal to, you know, the very simple shear stress tau equation is nothing but sigma x minus by 2 sin 2 theta tau xy cos 2 theta. So this is equation number 2 as it is. Now see equation 2 and 3. What we are going to do? If you see the common thing, instead of theta we have a 2 theta, only rest it is the same. So we want to see eliminate the parameters, basically 2 theta. Then what we'll do? Then simple, we have to check. We can do one thing. We can take the uh, equation first, which is nothing but a sigma n. Here see sigma n minus sigma x plus sigma y. So this sigma x plus sigma y, if you want, you can write the sigma average also, you can write. Okay, this sigma x plus sigma y by 2, it is average also, you can write here. The square and add equation 2 and 3. What you have to square and add. Right? So what you will get here, see, nothing but sigma n minus sigma x plus sigma y square plus tau square and add both, then equal to nothing but sigma x cos 2 theta tau x square and add sigma x cos 2 theta minus tau x. Sorry, this is sin 2 theta minus tau by cos. Okay, this one is clear here. Equation 2
Yes,
and
sir.
3, we are squaring and adding, right? So we can write sigma n minus sigma x plus sigma y plus tau. Now you open that bracket, first one, nothing but sigma x minus sigma y cos square plus tau square, this tau y, tau square xy sin square 2 theta a square plus b square plus 2 sigma x cos 2 theta into 2ab So into tau xy and 2. This is the first one. You have opened the bracket. Second one. So plus second one. Sigma x minus sigma y by square sine square 2 theta plus tau square cos square minus 2 sigma x sigma y sine 2 theta and 2 theta into tau xy into cos 2. Up to here it is clear, right? What I have done, this is the one bracket. This is the one bracket. I have opened a plus b square, a plus b whole square. Then another bracket a minus b whole square. I have just opened only. That's all. If you check, this part is what gone. Completely it is gone. Sin 2 theta, cos 2 theta multiplication we have. We can rearrange and we can cancel out. Now see this. Here what is the common? Uh, sigma x sigma y whole square. To take the bracket, what is the common thing? Cos square 2 theta plus this one, this part and this part I'm taking. Sin square, the one bracket. Okay, check it nicely. Second, I'm going to talk about plus tau x y square. This part sin square 2 theta plus this part cos square. Now see, to take sigma x sigma y by whole square, what is this value? 1 plus tau square xy, this value it is also. So ultimately you got sigma n minus sigma x plus sigma y by 2 whole square plus tau square value you got. This part is clear? Yeah. Coming to the again you have to segregate. See, you can write sigma n minus sigma x plus sigma y whole square plus tau square is equal to, you will write sigma x minus y whole square plus tau square value you will get. Now see, sigma x plus sigma y, you can write sigma average. But you can write sigma average. So sigma x plus sum divided by 2, it's your average. So you can write sigma n minus sigma average plus tau square is equal to sigma x minus sigma y by 2 whole square plus tau x. Now it's just like equation, if you remember, x minus a whole square plus y square is equal to r square. This is what, this is the equation of circle. This is what, this is the equation of circle, standard equation of circle, the equation of circle. And what equation you got here, it is also the similar. You just compare it. So sigma n you are going to draw on x axis. Okay, tau you are going to draw on y axis. Sigma average is what, nothing but it's a constant. Okay, and it will be used for the center analysis. That is one thing. And if you see r is nothing but radius. If you compare, what is the r square is equal to, you got that value, so r is nothing but, if you compare, so if you compare, what you will get, r square is equal to, you will have sigma x minus sigma y2 whole square, okay, plus tau xy square. What is the r is nothing but sigma x minus sigma y by 2 whole square plus tau xy, the root of. So this is what is nothing but radius of circle. What it is? The radius of circle. The radius of circle. All right. Now, whatever the constant you got here, basically, if you remember x minus a, is the standard equation, x minus a equation of circle standard. You have compared with this standard equation. Then this is nothing but, basically here you got the center. Center of circle will be sigma average comma the center of circle. So ultimately you got one circle. This is now more circle based, more circle. You can say for this more circle, we have, can draw the x-axis. On x-axis, just now you have seen it is nothing but sigma n is the normal stress. On y-axis, it is nothing but tau. Just now you have seen this is the tau. And we have to see the center is sigma average comma 0, means y value is 0 and x value is sigma average. So I can say this is the sigma average comma 0, means this is the center of the circle. Now you can take the circle here, can make the circle where the center is nothing but sigma average. Okay, so if the x-axis is nothing but, can say uh, sigma average, which is the x value, but it is not a radius. Sigma average is not a radius, because radius is sigma x minus sigma y by 2 whole square plus tau xy square. So radius and average, both value are totally different. Hence you cannot say that circle will pass from the origin. That circle can be anything. So I'm just making the center of this, and I can say now this is my circle. That's all. That circle can be anything, but center should be sigma average comma 0. That is my point. Let us see. So this is nothing but more circle. But this is the more circle simply. But the story is not ended up here. For the more circle, I can write center. Center of circle or center of more circle is nothing but, and what is the radius here? What is the radius? Radius is r. So I can say radius of circle r, and the center. Both values should be very clear. Sigma average comma 0 center. R is nothing but, just now I have derived here, sigma x sigma y by 2 square plus tau xy in root. Okay, this is the center and radius of the. Now coming to the how to draw it, construction of Mohr circle, that is very important, and that we have to perform now. That we have to perform. Okay, so first I will construction. I will prefer first. I will go for the construction. So very common points for the construction we have to write. Okay, common point for construction of Mohr circle. Common point. So one by one we need to write here. Why I said common point? Because Mohr circle can be very different Mohr circle will get with the different conditions. Suppose sigma x is given, sigma y is given, but tau xy is not given, then one Mohr circle you will get. Suppose sigma x and sigma y both are compressive, and tau xy, so one circle you will get. Suppose sigma x and sigma y both are tensile, then another circle you will get. Sigma x is compressive, sigma y is tensile, then another circle you will get. So what is my point? Few points are very common. Okay, so for the construction of Mohr circle, so that we need to write here. We write first point, we have a tau xy, that is clockwise. That is clockwise on the face resides above. I will show you. Resides above sigma axis. Okay, a tau xy anti-clockwise, anti-clockwise, anti-clockwise on a face, on face resides below sigma axis. Very simple. Meaning is, generally we are taking clockwise, which is positive, and anti-clockwise we are taking what they said. Because tau xy both clockwise and anti-clockwise both will be there. Just now here I have shown you. See, this will be the clockwise. See here, this will be the clockwise tau xy, and this will be the anti-clockwise tau xy about CG. Suppose this is the CG, so about this CG, this tau xy will be clockwise, this tau xy will be anti-clockwise. Similarly, this tau xy will be anti-clockwise. Okay, and so my point is, uh, sorry, this tau xy is the clockwise, and this tau xy is the anti-clockwise. Now see, about this CG, this tau xy will give clockwise moment, and this tau xy will give anti-clockwise moment. Similarly, this tau xy will give the clockwise moment, and this tau xy will give the anti-clockwise moment about CG. So two tau xy you have, one will be the clockwise, another will be anti-clockwise. And below sigma, so where is the sigma? Sigma is on x-axis. So you have to draw the sigma first for this particular statement I'm saying. Suppose this is the sigma now. So here it is clearly mentioned, if there is the clockwise tau xy, then phase resides above sigma xy. So if suppose this is sigma, so tau xy, one tau xy which is clockwise, it will be above sigma axis, see, and which is the anti-clockwise, it will be the below sigma axis, means this is the anti-clockwise tau xy. I have shown you which one is the clockwise, which one is the anti-clockwise. See, if you check the stress system here, so this tau xy is the clockwise. Okay, this will be the anti-clockwise. Similarly, this will be CLK clockwise, and this will be anti-clockwise. Okay, so two stress system we have, one is clockwise, another is anti-clockwise. If it is clockwise stress system, then you have to draw above the sigma axis. If it is anti-clockwise, you have to draw the below the sigma axis. Okay, this is the done. This is the first statement you have written. Coming to the second statement, which is common for all. Second statement is nothing but a tensile stress. Listen carefully. A tensile stress tensile stress will be positive, that we know, positive, and plotted plotted right of origin, right of origin, or you can say center, right of origin O, comma, compressive stress will be negative and will be plotted left to the origin or center O. What is the mean of it? Suppose just now here I have drawn, just make it, this is the origin. So about origin, draw here, this is the origin now. If it is tensile stress, tensile means positive. So we have to plot right to the origin, means all the positive stress will be this side. Okay, anywhere. This is the positive. And if it is compressive, then we have to plot left. This is the negative. So negative means what? Compressive stress system. Anyone, sigma x, sigma y, anyone. If it is compressive, then we have to plot this side. And if it is tensile, which is positive, we have to plot this. That's the mean of. Okay, this is the very clear. Suppose we have sigma x, which is tensile, but sigma y, which is compressive. Sigma y is what? Compressive. So we have to mark sigma y left side, means somewhere here. This is now sigma y, because sigma y is compressive, which is negative, and sigma x, which is tensile, so we mark right side. This is positive. That's the mean of it. Okay, this is the common point again. Okay, the third very important common point is for the circle, because generally we know the theta is always angle is what? Always theta. Okay, but in this case, if you check all the equation we had seen here, in terms of theta is not, angle is not theta, it's a 2 theta. Everywhere you can check, everywhere theta is nothing but 2 theta in the formula, sine 2 theta, cos 2 theta you are getting here, right? So what you are going to do, you are just an angle theta, you have to make a note of it, an angle theta on real plane, transfers as an angle, as an angle 2 theta on Mohr circle. Okay. Angle theta can real plane transferred as an angle 2 theta. True, on Mohr circle, an angle theta on real plane transferred as an angle 2 theta. Okay, on Mohr circle. So wherever we are going to measure, we have to measure the 2 theta angle. Now coming to the very special cases, I told you many different Mohr circle you can draw, just like a sigma x and sigma y. There is no tau xy, or sigma x and sigma y with tau xy, or sigma x is compressive, sigma y is tensile without tau xy, or sigma x is negative, sigma y is positive with tau xy. All three are negative, all three are positive. Many cases are there, right? We are going to take one very specific case, which is nothing but sigma x and sigma y. Okay, sigma x and sigma y with tau xy. We are going to discuss with tau xy, that is the important part here we are going to discuss. So this case is nothing but I just draw. Next case I have to take construction of Mohr circle. This is important now. So we have to give the heading construction of Mohr circle. Construction of Mohr circle for complex complex state of stress. That is, what is the complex state of stress? That is sigma x comma sigma y and tau xy known. This is the case you are going to discuss. Okay? Sigma x, sigma y, and tau xy. We have sigma x, we have sigma y. Okay, we have sigma x, we have sigma y, and we have tau xy. All three are available now. Now for this we are going to draw the Mohr circle. So we have to follow the steps here. One by one step we have to follow. Step number one. We have to follow the steps. So what is the step one? Step one is label the element A, B, C, D and draw all stress. So maybe in examination it will be given, okay, all the stresses may be labeled A, B, C, D. A, B, C, D, right? A, B, C, D. All the stresses we have to draw here. It is nothing but sigma x, sigma y. Now we are also having tau xy. Okay, these all are the stresses. This is step one. We'll go for the step two. Step two. Step two. Set up axis. Set up axis for the direct stress. For direct stress. Okay. On x-axis and shear stress, that is on coordinate on y-axis. Have to set up all the stress. We have to draw x-axis. On x-axis we have to draw direct stress. Direct stress means normal stress. So this is what sigma, and this on y-axis it should be shear stress. No, shear stress on y-axis. Axis is what set up. If you go this side, then it will be minus sigma, means compressive. If you go this side, it means minus shear stress, which is the anti-clockwise. This is the anti-clockwise. This is the clockwise. That's the mean of it. All right. Now coming to the next step 3. If you see the step 3, now we have to go through the diagram using the sign convention. We have to see sigma x and sigma y. Sigma x and sigma y both are both are both are the tensile stress. We have to take positive. I told you, once you it is tensile stress, all the stresses you have to draw right side to the origin. Suppose this is the origin, so where is the stresses? Sigma x and sigma y. it will be right side. So see, all sigma x and sigma y, this is also tensile. Sigma x tensile, sigma y is also tensile. So both stresses I have to draw on right side to the origin O. So I can make a point. See, this is one point. I can say here this value is nothing but sigma y, and somewhere here I can say this is nothing but sigma x. I can say this is nothing but sigma x. Okay, one thing. Second thing, we also have to see the tau value. See, this is what clockwise. So once it is clockwise stress, so it will go on the above to the, it will go above to the sigma. I have given point, common point one. So above to sigma. So this is nothing but tau xy, which is clockwise. I have to draw clockwise. The clockwise, which is above to the sigma, or to the sigma. So this is nothing but tau xy. Okay. Also, we have to see tau xy, which is anti-clockwise. This anti-clockwise tau xy, which is below. These points I have given here, common. See this one. This is the positive, and this is the negative. I explain. So the tau xy you have to represent here. This one is represented. Now simply you can give the name. This is O, this is M, and this one you can give the name L. M and L you can give the name. This one you can say this is what T and this is what S. Different naming you are giving. Okay. So you got the stress system here. Now coming to the, and always you just follow the instruction, like what is the OL? What is the OM? See, first OM is nothing but sigma y. What is OL? Is nothing but sigma x. What is MT and LS? Both are tau xy, but plus minus. If you talk MT, it is plus tau xy, LS is the minus tau xy. This is the mean of it. Always remember this. Now, what is the next step? This is the step 1, then 2. We'll talk about the step. Okay, on this only I have drawn. This should be on this line, step 3. Anyway, no issue. What we have done, this is the step 3. Coming to the step 4. What is the step 4 here? Step 3 just now I have shown you. Previous diagram I have drawn the same thing. This is the basically, there it is nothing but sigma. This is what tau is, value of, can say L. Okay, here this is x, this is S, tau xy. Similarly, this is nothing but M, this is tau xy, and obviously here is nothing but sigma y. So automatically you got here the points is in O. So OM is sigma y, OL is nothing but sigma x, MT tau xy clockwise, and LS is nothing but tau xy AC anti-clock. That's the mean of it, right? Now coming to the step 4. Coming to the step 4. Coming to the step 4. Join ST. Where is the S? S and T. See, this is the point T here. This is point S here. We have to write join S T, and it will, and it will cut, it will cut 0 sigma. Where is Mean, what is the mean of 0 sigma? Where is the 0 sigma? From 0, this is the origin, which is O, you can say O to sigma, not 0, O to sigma. O to sigma. Obviously, if you join S and T, so O sigma will be cut somewhere. So O sigma axis at C. So where it will cut the O sigma axis, that point will be C. And this is as center, and CS, I'll show you, CSR and CS and CT as radius. As draw circle, because once you got the radius, draw circle, that is more circle. Is simple now. See what they are saying. Very simple. Just now you have drawn. Concentrate here. Here, very simple. This is sigma. This is tau. This is origin O. Side not have any compressive stress. Left side not draw any stress. Till now, what where we reached? We reached at this point. This is called sigma y. We reached this point. This is called sigma. And we have to draw one. Have to draw. This is the sigma y, okay? And this point is not. We have to draw the shear stress clockwise first. So we'll draw the clockwise, anti-clockwise shear stress coming here. This is nothing but point. If you check, this was M, this point was L, this point was T, and this point was S. Remember. So they are saying simply you just join ST. So we are joining ST. Join now. It will cut O sigma. So O sigma means X axis, they are saying X axis. So axis, it will cut O sigma axis at C. So where it is cutting, you just give the name C. Okay. As center. Now this C is what as center. Okay. So CS, see this CS, this side, we are talking about this CS. See this side. This CS will be radius. Obviously, this and this will be same because both are radius. So CS and CT as radius. Now, once you got the radius, draw the circle. So if you draw the circle, this will be your center. So where is the circle now? You have radius, you have center, so you can use the scaling and all. You can draw the circle. Your circle will be somewhat like nothing but this will be your center. So you can make, because this is now radius. Maybe I'm not able to draw proper circle. Circle will be something. This you have to touch because this CT will be radius, CS will be radius, CT and CS. You can write here CT and CS is nothing but radius. Okay. O, what is called OM, sigma Y, OL, sigma X, MT, tau XY, clockwise, LS, tau XY, anti-clockwise. Right? Done. Now, so if we see, this is nothing but radius R. Similarly, here also downside, your choice, both side you can. Now, where will be 2 theta? So, because in formula, if you see 2 theta also we have. So, where is the 2 theta? Theta somewhere around here. Have to measure this. This will Have to draw this. All right, this is 2 theta. So wherever you are getting this, this point is not. Draw the perpendicular. This point is nothing but Q. Okay. So what is this PQ? What is this PQ? PQ is nothing but the tau. The tau. PQ is nothing but tau. And this is the whole length horizontally. This value is nothing but sigma n. So what is the PR? Sorry, this point you can make R here. No issue. So PR is nothing but sigma. What is your ultimate job? To get sigma n and tau. So you have to take angle 2 theta, give the arc, and you cut the circle. So when you are cutting the circle, you will get point P. Draw the perpendicular. So PQ you will get. So this PQ is just parallel to tau, and that will give the shear stress. That will give the shear stress on oblique plane, and horizontal x-axis will give the normal stress. So from point P to this vertical line, to check the measurement, this length will be PR, and this PR is nothing but sigma n. That's all. That was your job to do. Okay, that was your finding the value. Now it is completed. So conclusion I need to write here. I need to write the conclusion, because then step 4 or step 5 also if you want to mention here, because total 6 step we have. Better you complete all steps. Step 5. What is the step 5? At the center, at the center, draw a line. Draw line CP. See at the center, CP. I have drawn one line here. I shown you. This line is nothing but C. At an angle, CP at an angle 2 theta in the same direction, same direction as the normal to the plane, normal to the plane makes with direction of sigma x. Okay, so from the center you have to draw one line P and making angle 2 theta from the horizontal plane stress. Okay, sigma x. So you will get this circle, whatever we have shown you, this line. Okay, now coming to this valuation, if you check what is the OC, what is the OC? Now final I will draw who's the circle now. For this circle now, roughly I am drawing here. So this is the center point. Okay, for the center, if you see, is now C. This was, if you remember, it was T. This was M. This was L, and this was S. Previously, I have drawn like that. Now I am saying you just draw one line CP here, and it is at angle 2 theta. You have to mark, and then you have to draw the perpendicular. This is P and this point. So once you check the location of P from the vertical axis horizontally, this length, so this is nothing but 6, and this PQ, this length, nothing but tau. So what you got here, you got PQ is equal to tau, and P, this name you can give R. So PR is nothing but this two value on oblique plane, You are interested to calculate this sigma n and tau. You see the first diagram. What was the unknown here? Was the unknown here? See this diagram. ABCD you have drawn somewhere. This one. ABCD you have drawn. If you check here on oblique plane, where is the oblique plane? The oblique sigma n tau. So this sigma n and tau you have to calculate by the graphical. This sigma n and tau is just now here you have calculated. That value is nothing but PQ and P. All. This is the all story. Now conclusion if you write step 5, 6. From the Moore circle graphical method, what is the conclusion? Okay. So you got here that center you got. First got what is the center of this? The center is nothing but OC. So OC is the center. Center is nothing but OC. Calculate value it will number 1. Number 2, radius. Radius. What is the radius? Where is the radius? C. Radius is nothing but CS. CS or also it is nothing but CT. CS or CT. To check value of CS, you can say CS is nothing but C. You can say CS is nothing but CL plus LS square and root. So CS is nothing but C. This CL square plus LS square. So CL square plus where this is the radius. Okay, you calculate, you will get it. PR is nothing but sigma n and PQ is nothing but third normal stress on oblique plane. So normal stress you check, it is nothing but P oblique plane. And last is shear stress on oblique plane, that is CP. Sorry, PQ. Q is the shear on. All right.